section, we will learn about the polynomials and their classification according to their power. That is, degree of polynomials. In the last class, we learnt about algebraic expressions. These are a few examples. In the given expressions, x, y, and z are called variables. Numbers associated with these variables are called coefficients. And the numbers whose values are fixed are called constants. Now, if we focus on the powers of these variables, these are positives, negatives, and fractions. And friends, the only difference between polynomials and expressions is that the power of variables in polynomials is always a whole number, whereas the power of variables in expressions can be any number. Here, we have to focus on one thing, that all polynomials are expressions, but not all expressions are polynomials. Friends, in the given examples, polynomials are in one variable only, and such type of polynomials are called as polynomials in one variable. Can a polynomial be in the form of two or more variables? Yes, but we will learn those polynomials in higher classes. General form of polynomials is expressed in this manner, where x is called variable, an minus 1, a1 are coefficients, and a0 is a constant. Polynomials are expressed as p of x, q of x, or according to the variables p of y, r of y, or r of t, q of t. Polynomials are also classified based on the number of terms present in the polynomials, such as monomial, binomial, trinomial, etc. Similarly, polynomials are classified based on the degree of polynomial, such as polynomials having degree 1 are called linear polynomials. Polynomials having degree 2 are called quadratic polynomials, and polynomials having degree 3 are called cubic polynomials. Friends, if you observe the general form of these polynomials, it has been stated that a should not be 0. Do you know why? If a becomes 0, then the degree of polynomials reduces by 1. If, in the general form of cubic polynomial, we put 0 in the place of a, then its degree reduces by 1 and becomes quadratic polynomial. Similarly, quadratic will become linear and linear will become constant polynomial. Let's assume that there is an expression whose power is 0. For example, 5 times x to the power of 0. Then, would it be a polynomial? During such dilemmas, we should focus on the definition, which says that if the power of any expression is a whole number, then the expression is a polynomial, and 0 is a whole number. Hence, it is a polynomial. The value of x to the power of 0 in 5 times x to the power of 0 is 1. That is, 5 times x to the power of 0 equals to 5, means any number can be written as the polynomial with power 0. Now, this means that constant or numbers are also polynomials. They are called constant polynomial. Is number 0 also a polynomial? 0 can be expressed as 0 times x to the power of 0, or 0 times x to the power of 3, or 0 times x to the power of 5, or as a power of any variable. So, 0 is called a zero polynomial whose power is not defined. Friends, we have come to the end of this video. So today, what have we learned? Yes. In the last video, we learned to recognize polynomials and also discussed classification of polynomials based on the number of terms and the highest power of variable. Today, we will learn to solve few questions based on those topics and will enhance our knowledge on the polynomials. So, let us start. The first question: which of these expressions are polynomials? And classify them based on the number of terms and the highest power of the variable. To answer the question, you can pause the video. The first expression, x to the power of 3 plus 3 to the square root of 5, has only a single variable x, whose highest power is 3. And there are two terms, x to the power of 3 and 3 to the square root of 5. This means it is a cubic binomial in one variable. In the second expression, minus 3t square plus 2 square root of t minus 1 by 4, there is only one variable t, whose highest power is 2. But if we see the second term square root of t, its power is not a whole number. Here, the power of t is 1 by 2, means this expression is not a polynomial. The third expression is very simple. It is a constant polynomial with power 0. Now, let's solve another question. You have to write the coefficient of x square in the given polynomials. Such questions are quite easy. Just that we have to focus on x square and have to write its coefficient. In the first question, square root of 2x square minus 3x plus 9. What is the coefficient of x square? We can directly say square root of 2 is the answer. Now, let's go ahead and see the expression x plus 2x to the power of 3 minus 5 by 4. Here, x square is not present in the equation. Now, how to find its coefficient? This expression can also be written like this, where the coefficient of x square is 0, and hence this complete term is 0. In an expression of polynomial, if the x squared term is not present, then its coefficient will be 0. The next polynomial is x square minus 7. Will the answer be 0 in this case also? No. If x to the power of 2 has no coefficient, its coefficient is taken as 1, because on multiplying any term with 1, we get the same term. Let's see our next question. Here, we will have to write an example of a trinomial in which the highest power of the variable is 15. The answer to this could be as follows. X to the power of 15 plus x to the power of any whole number other than 0 and less than 15 plus any number other than 0. Here, you can also write the coefficient of x to the power of 15, which can be any number other than 0. Got it? Before we end, here's a question that you have to solve yourself. Write an example of a binomial in which the highest power of the variable is 145. So friends, in today's video, we learned to recognize the polynomials and also learned to solve a few questions based on their types. In the next, we try to answer them correctly. So, let's start with the first question. From the given expressions, identify which is not a polynomial. You can pause the video to think over. The first option is 2x square minus square root of 3x minus 1 by 2. Here, in the second term, x is also within the root with 3, which means the power of x is 1 by 2, which is not a whole number. So, it is not a polynomial. The second option is y to the power of 6 by 2 minus 3y square minus 5. Here, in the first term, the power is 6 by 2. It is a fraction, but on solving it, becomes 3, which is a whole number. Powers of the rest of the terms are also whole numbers. Hence, this is also a polynomial. Now we have the third option. Y square minus 1 by y plus 1, where y is not equal to minus 1. Friends, on seeing y plus 1 in the denominator, straight away, do not say that it is not a polynomial, but try to simplify it. Like using algebraic identity, a square minus b square is equal to a plus b a minus b, the numerator can be written as y plus 1, y minus 1. This would become y minus 1 by cancelling y plus 1 from numerator and denominator. Hence, it is a linear polynomial. Friends, to recognize any polynomial, we should focus only on the powers of the variables. Let us now go to the next question. Find the degree of polynomials given below. The very first option seems to be a little doubtful. Some of you can say that this is a linear polynomial. But friends, in such condition, we should always simplify the expression. On solving 2x minus 1 into x minus 2, we get 2x square minus 4x minus x plus 2, which in turn is equal to 2x square minus 5x plus 2. Now we can say that this is a quadratic polynomial. Let's see the second option. The power of variable of the first term is 4, but it is not the highest. Fifth term of this polynomial is x to the power of 5, where the power of x is 5. Hence, this is a polynomial with the degree 5. It would be better to write such polynomials in the descending order of their powers. The third option is quite different from the other two. Is it a polynomial? Yes, it is a polynomial with two variables, where the variables are x and y. We just need to focus on the highest power. Here, the power of the variable of the third term is highest 6. That is, this is a polynomial with degree 6. So friends, let's finish this video with this and see you in the next video. In the next video, we will learn about the roots of the polynomials. Thank you.